Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, I'll use implicit differentiation to find dy over dx for these two given equations. Let's start by understanding why we need to use implicit differentiation for these two equations. The first equation is y squared plus x equals 5. In this equation, y is not isolated on one side of the equation. If we isolate y on the left side of the equation, we have to move x to the right side of the equation. We get y squared equals negative x plus 5. Next, we have to get rid of the square on the y, so we have to apply square root to both sides. The result of that is we get two cases, plus and minus. In order to avoid the confusion on which case to use to find dy over dx for this equation, we use implicit differentiation to find dy over dx. There is a very important concept we need to understand to solve this type of problem. So we will use the given equation y squared plus x equals 5. We have to find dy over dx, so we have to find the derivative with respect to x. The first term in the equation is y squared. We have to use chain rule to find the derivative of y squared because this term has the inner function y and the outer function is the square on y. As per chain rule, let's start with the derivative of the outer function. We have to use power rule for the outer function. As per the power rule, we should move the exponent 2 to the front of the term and subtract 1 from 2 times the derivative of the inner function, which is y. So we get dy over dx. This is the derivative of the first term, y squared. The derivative of x with respect to x is 1. 5 is a constant, so its derivative is equal to 0. We have to isolate dy over dx in this equation. The first step is to move 1 to the right side of the equation. We should subtract 1 from both sides. Y to the power 1 is just y. Next, we should divide both sides by 2y. This should be the final answer for the first equation. Now we can analyze the second equation. We have to use implicit differentiation for this equation because if we isolate y in this equation, we get the plus minus cases. We have to find the derivative of this equation with respect to x. Let's start with x squared. As per the power rule, the derivative of x squared is 2x. We move the exponent 2 to the front of the term and subtract 1 from 2. In the next term, 4y squared, 4 is the coefficient of the term. It'll stay as it is. We can use chain rule to find the derivative of y squared. The inner function is y. The outer function is the exponent 2. We start by finding the derivative of the outer function. We have to use power rule. We should move the exponent 2 to the front of the term and subtract 1 from 2 times the derivative of the inner function y. This is the derivative of the term 4y squared. 64 is a constant, so its derivative is equal to 0. Now we can simplify this equation. X to the power 1 is equal to x, y to the power 1 is equal to y. We have to isolate dy over dx in this equation. We should subtract 2x from both sides. Next, we should divide both sides by 8y. We can reduce this fraction. This should be the final answer for the second given equation. So these are the steps you have to keep in mind to use implicit differentiation for equations like these. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.